Welcome to the notes for 6.4. Today we're going to look at graphs of tangent and inverse tangent functions. To get started, let's quickly review the graph of tangent function so that we can graph the inverse tangent function. So starting out, remember tangent has a period of pi radians. So when we look at it, just looking back at our unit circle, we're going to create a little table. And when we start out here, just think about looking at your unit circle. And when we think about our different angles, for instance, here, and we think about our angle of 0 radians, when you take the tangent of 0 radians, remember you're doing your y over your x, so that'd be like 0 over 1. So the tangent of 0 radians was 0, so we'd have that point at 0, 0. And then we look at our point that ends up being at pi over 4. And remember that tangent is the same thing as the slope of the radius in your unit circle. So when this one at pi over 4 ends up being at the point, radical 2 over radical 2 over 2, comma, radical 2 over 2. So when you do y over x, you end up with 1. So for pi over 4, our output would be 1. So the tangent of pi over 4 is 1. And then we go to our angle pi over 2. And because that's a vertical line, we know that vertical lines have a slope that's undefined. So when you try to do 1 over 0, you get a fraction that's not possible. So that's why we get undefined here. So our angle would be pi over 2, and the tangent of pi over 2 would end up being undefined. And then when we went over to 3 pi over 4, this one's just like our pi over 4, but it's going down to the right, so we know that our slope would be negative 1. So our tangent for 3 pi over 4 is equal to negative 1. And then the last angle, right, when we get over here to pi, again, we're at a horizontal line, so our slope ends up being 0 again. So the tangent of pi is equal to 0. Now that we have those points, let's plot those on our graph. So starting out with the point 0, 0, and then when you look at our scale, we are at, it goes over by pi over 4. So we'll say pi over 4, 1. And then at pi over 2, or half pi, it's undefined. Remember, that would be a vertical asymptote that runs right down here. And now when we jump over again to 3 pi over 4, our output would be negative 1. And then at pi, we're back at 0. Right? And if we continue on there, if we went to our next angle, right, if we were at 5 pi over 4, right, our output should be 1. And if you don't see that there, just look at your unit circle. Here's where 5 pi over 4 would be, right? And it has the same slope as pi over 4, right? So that output was 1. Then you're down at the bottom here at 3 pi over 2. Again, now that's a vertical line. So we'll take that and put in another vertical asymptote. All right, remember, since it's periodic, it's going to continue to repeat itself. So after we jump over our vertical asymptote, right, as we jump over here to the other side, it's going to look the same as it does when we jump over here. So we're going to have a point down here at negative 1. Now let's go backwards. Let's jump all the way back over here, right? You see how these 3 points kind of go like this? So now we're going to have this point here at negative pi over 4 would be at negative 1. We have another pi over 2 angle, which is going to be another vertical asymptote. When we jump back across, right, we're going to go back up. See, like we did here, we're going back up here. We're going to jump back over to here. Okay, so we'd have a point here, a point at 0, a point at negative 1, and then another vertical asymptote. Okay, so let's go ahead there and connect it. We know that our tangent function looks something like this. It runs right along our vertical asymptote, curves up like this through those points, and then runs along the other vertical asymptote. Same thing, I guess I could put that part in there. And it continues to do this over and over again. which is why it's a periodic function. So let's look now at what happens with our inverse tangent function. Remember, we're not looking at reciprocal, we are looking at the inverse. So what's going to happen with our points is the x and the y values are going to flip. Okay, so 0, 0 is going to remain the same, but then my output here would be 1 pi over 4. So basically, remember, here's these points right here are switching, right? Our x's and y's are going to switch on each of these. So we're going to say we have a point that is undefined, and then pi over 2, we have -1, and then 3 pi over 4, and then the last one here would be 0, and then pi. So let's plot these ones. Notice the scale changes on our y-axis. Okay, we have kind of our traditional radian values on there, and then this one is more broken down into just single units. So we'll plot these on our coordinate plane. So we got 0, 0. And then at 1, we're at pi over 4, which would be about right here. And then it says we're undefined where our outputs are at pi over 2. So if we think about where are all of our outputs pi over 2, right? All of these have y coordinates of pi over 2. So we're going to be undefined at that unit. So we're going to say that would be like a horizontal asymptote in this case. And then the next point we see is 1 pi over 4. So if we go, I'm sorry, -1, 3 pi over 4. So at -1, we're up at 3 pi over 4, which would be right up here. Oops, sorry, my pen wasn't working there. And then at pi, we're back at 0. And you kind of see we have like the same thing going on as with our tangent function, except we're going up and down instead of completely left to right. So we can continue to follow our pattern, right? We would have a point here at 3 pi over 2. We should have another horizontal asymptote. And if you want, you could go ahead and put in at all the pi over 2 angles, you can put in those horizontal asymptotes so you can kind of see what's going on there. And we'd have a point here. At negative pi, we'd be at 0. We'd have a point in here. We'd have a point here. Okay, now our graphs are going to run horizontally now with our horizontal asymptotes the way they did with the vertical asymptotes in the regular function. So this is what our inverse tangent graph is going to look like. You can get on there and then just know that, yeah, we're going to have another point, that's here, and then we'd have another one that runs here up through, oops, I messed that up there. It should be here. Doesn't matter, we don't really need that one anyway, so we don't need to go all the way across in that. Okay, so this is what our inverse tangent is going to look like. However, as we go on here, they say, how can we restrict the range so that it is a function? If I look at it right now the way it is, if I try to run a vertical line down through it, you notice that I hit multiple points on this graph that have, the same output. So like if I plugged in, let's say, even just 0, right? I get an output 0 pi, and then I'd have, another one up there, or as I go down, I'd be hitting them there. So the way it is right now, it's not a function. So what we're going to do here is we're going to restrict the range on it there so that we do have a function. So there's only one output for each and every input. And so here's what that's going to look like. We're going to go ahead and we're going to just think about cutting out just this center part of it right here. Okay, so between our asymptotes at negative pi over 2 and pi over 2. So we can start out here. Let's draw those in first. So we have that vertical asymptote right here at pi over 2. And we have I'm sorry, I didn't mean vertical asymptote, horizontal asymptote at negative pi over 2. And let's take it now, and we had a point at 0, 0, point at 1 pi over 4, and then we have one at negative 1, negative pi over 4. And so the function ran right along here. Now we've restricted the range so that if we were to try to run a vertical line through it, right, we would only hit the function in one place. Therefore, this is now going to be a function. This is our function. Y is equal to the inverse tangent of x. This is really important for us because remember when we're plugging in anything into the calculator using the inverse tangent, it only gives us one output there, right? So when you look at it here, right, when we have the function set up this way, it's only going to give us one output when we type anything in. But let's think about like what do we have here? So our range right now, right? Our range was restricted from, we'd say, negative pi over 2 to pi over 2. And if you think about it in like the decimal form, like what is negative pi over 2, like when we type it on the calculator there, right? It's like negative 3.14 divided by 2, you get negative 1.57 to positive 1.57. So anytime we type in uh, a value into the calculator there, the inverse tangent of something, it's always going to spit out a value somewhere in that range. Okay. Now notice our domain here, right? Our domain for this one is going to end up being all real numbers. So negative infinity to positive infinity, because it's going to go on and on from left to right there. We can plug in any of the values and it's going to spit something out. And that's because remember, when we look at the original range, right, from our tangent function, right, the original range could be anything, right? So it's all real numbers there, which is why our domain ends up being all real numbers in our range. So the next question is, so in which primary quadrants does the inverse tangent lie? So as we think about what we did yesterday with inverse cosine, right, and inverse sine, what quadrants they lived in, we're going to do something similar with tangent. So let's look here at kind of our values that we have kind of run from talking about, right? From negative pi over 2 to pi over 2. So think about like, if we're thinking about a unit circle, where would those values be? Well, it looks just like our sine, our inverse sine function, right? This would be negative pi over 2 down here, and we'd be at pi over 2 up here, right? So when we plug in, right, it's going to spit out an angle from up to pi over 2, or if we're going in the other direction, be down to negative pi over 2. That's all it's going to give us. So it looks like our inverse tangent function, right, is going to live in quadrants 1 and quadrant 4. Okay, so this is where our inverse tangent function lives. Okay, remember, this is also where our inverse sine function lives. So this is nice because these two kind of use the same, they live in the same areas, the same quadrants. Now, just quick review, we also had our inverse cosine function yesterday. And remember that inverse cosine function lived in quadrants 1 and 2, right? Because it was going to spit out a value between 0 and pi when we type it in there. So we get something here in quadrant 1 or a quadrant 2 angle. Okay, so tangent, inverse sine live in the same quadrants, and then, you know, inverse cosine has its own thing going on there. All right, so let's move on here and see how this is going to be useful for us in today's lesson. So it said find the radian value of each without a calculator. So the first one here, we're just given the inverse tangent of the square root of 3. Okay, so when you think about it, and you can pull up your 1, 2, 3, 3, 2, 1 chart if you need to, but when we look at where would we find inverse tangent, before we do it, let's take it here since we're not using a calculator. Let's take it and let's draw that inverse tangent function. All right, we're thinking about it's going to live in these two quadrants. So remember, this down here is negative pi over 2, and this is pi over 2. And I would draw this every time I'm asked to do this without the calculator, just to help it stick in your brain a little bit. So the square root of 3, right? Square root of 3 is going to be a positive value, right? So it's going to be up here. Think about what angle has a tangent of radical 3. And if you look at your, your 1, 2, 3, 3, 2, 1 chart, if you're using that, I'm not going to drop the whole thing there, right? But we know that that ends up being right over here, right? So we have tangent would have been down here, and we would have had up here, this was our pi over 3 angle, right? And this is where the square root of 3 was, if you're referring to that, right? So that's where that was. So this is a pi over 3 angle. Sorry, I don't know why my pen is messing up here. So we've got, there you go, that's better. Our answer here then would be pi over 3. Now, if we want to check it, right, let's just check it real quick just so we understand there. If we say pi over 3, we're going to do inverse tangent of the square root of 3. Right, it gives us the value 1.04719, right? So just to check it, let's just do second pi divided by 3, and you can see that's the angle that it's giving us. Okay, so let's move on here to the one on the right. Says inverse tangent of negative radical 3 over 3. Again, since it's an inverse tangent function, we're thinking about where's it going to end up being here. So we know the output's going to be between these two. And if it's a negative, right, we know it's got to be down in quadrant 4. And negative radical 3 over 3, right, it's going to end up being right here. Okay, if you're thinking about your 1, 2, 3, 3, 2, 1 chart, that's over here, radical 3 over 3. What's the angle? Well, we're talking about a pi over 6 reference angle. Okay, so if we're going down this direction, we know then that's going to be a negative pi over 6. So our angle here would be negative pi over 6. And, again, you want to check it. Do inverse tangent of negative square root of 3 over 3. See, we get negative 0.5235, right? And then let's just take that here and do, whoops, I don't need second. Let's do negative pi over 6. And you see you get the same value, right? So that one we know is correct. Now, the next one here, you see we have the arctan of 0. Remember, that is the exact same thing as saying the inverse tangent of 0. Okay, arctan means the same thing if you didn't pay attention to the previous lesson, but that is what it is. So if they are the same thing, you're going to do it the same way. But let's just take it here and let's draw it in. Here is our graph for our table, not our table, jeepers. Just our plot of our inverse tangent function. Sorry, I was distracted there. I'm back. So we've got pi over 2. We have a negative pi over 2. And we're talking about 0. Okay, so think about it here. We could jump all the way back up to the unit circle here, right? Where was our tangent equal to 0? It's equal to 0 along this line, right, where it's horizontal. So our angle that we're looking at for this one, right, is going to be right along here. So this is going to be talking about our angle at 0, radians. So that means the inverse tangent of 0 is 0. Again, you can type it on the calculator to check it. Let's move on to the next part then. So last slide of this lesson says evaluate each and simplify. So we have the expression 3 times the inverse tangent of -1 plus the inverse cosine of negative radical 2 over 2. So what we're going to need to do with this one is we're going to have to break this one into two parts, kind of like order of operations. Let's focus on simplifying this, and then we'll simplify that, and then we'll add them together. Okay, so remember, we are going to do 3 times, okay, our inverse tangent of -1. So let's do our inverse tangent of -1 first. We're thinking about, here we are. Okay, so when we do this part of it here, we've got, come on, right, what's going on? There we go, pi over 2, negative pi over 2. Okay, so where is our tangent going to be -1? So thinking about your slopes, right? We don't want the positive one, we want the negative one, which is down here. So this is going to be a negative pi over 4, right? So because negative pi over 4 is going to give us a slope of -1. So this part of it right here is equal to negative pi over 4. So we're going to do 3 times negative pi over 4, which in this case then is going to give us negative 3 pi over 4. And then we're going to be adding to that. Let's see what we get here. Let's do the inverse cosine of negative radical 2 over 2. So we'll take it here and let's just draw that in here. So we know it lives between 0 and pi. And since it's negative radical 2 over 2, we know that that would be back here, and it is at our pi over 4 angle back here, which in this case, in the second quadrant, would be 3 pi over 4, right? Think about it. This one has that point, negative radical 2 over 2, comma, radical 2 over 2. What we're focused on there, right, is this piece of it. Get off of there. All right, so let's take that and let's substitute that in here. So we've got 3 pi over 4. So when we add these two things together, right, we end up with 0. And you can take it and type it on the calculator if you wish to check it. And we got one more to do. We've got tangent squared of cosine, inverse cosine of -1. So again, order of operations, let's start in here. So the first thing we're going to do is do the inverse cosine of -1. Remember that one lives in quadrants 1 and 2, so we're thinking about it here. Like I said, it seems tedious sometimes, but like to draw it out, it's just going to help you to remember which quadrants they live in and just to guarantee you're not making little simple mistakes. Where's the cosine equal to -1 at? Well, that's where we're at that point, -1, 0 over here, right? Cosine is equal to -1 there. So we're talking about this angle that opens up to here. So what angle is that? Well, that would be pi, right? So this is the same thing as pi radians. Let's bring down our tangent squared. So we're doing, basically, this is going to be saying here, we're taking the tangent of pi, right? And then we're squaring that value. Okay, remember, this isn't inverse tangent, this is just regular tangent. So what is our tangent of pi? Okay, and when you think about your, if you're going to draw it out one more time, this one though, I'm just doing it like it's the unit circle here, right? At pi, we know that we're at the value -1, 0. And since tangent is equal to like our y over our x, right? We'd have 0 over -1. So this would end up being 0. So we'd have 0 for our tangent of pi. And 0 squared is going to end up equaling 0 again. So there's our output again, is 0. All that for some zeros. Okay, so they won't all be 0, just letting you know. But if you have additional questions, please make sure you reach out. Otherwise, thanks for watching.